Hello everyone, welcome to letsgo.xyz. So this is going to be our last video tutorial of this course. So let's get straight into it. In the last video we did the standardization of a dataset. Now we are doing this principal component analysis. What it's actually going to do is it's going to take all the features or attributes that we have, and then it's going to reduce the dimensions from whatever it is to like 23. So the value that you specify here should be less than the actual number of dimensions, and then it's going to like reduce it to whatever value that you're specifying there. So I'm actually using that PCA principal component analysis from scikit-learn decomposition library. So I'm calling the function saying that I'm calling the class saying that I need only 23 components in our features, and I'm calling this fit and transform function in that class to like do the transformation for me. So we have this standardized, we have this do PCA function. So we pretty much covered almost all the best practices that we have to follow to model our machine learn data for our machine learning. So I'm doing PCA, and then I'm actually doing the standardization. Okay, so now what I've done here below here is I'm calling the rest of the steps. So in the fifth one is to choose the machine learning model. So in that case I've chosen perceptron. Sixth step is to train the model, so I'm doing the training, and then the seventh step is to like to do prediction. So basically I'm calculating the accuracy and I'm printing it out, and then I'm actually doing some prediction. So I'm doing taking the actual value from y test, and then I'm also predicting it. So and then we can actually visually compare like how it is, whether it's right or wrong. Pick any random values from the test set as well as do prediction on the same row of data and then see how it matches. So I'm doing that for, so that's perceptron. This is logistic regression, and then SVC support vector machine. Kernel one is RBF, another one is linear. Okay, I'm doing the same for like all. So now actually I'm going to save this and execute this, then see what's the accuracy that we're getting. So the accuracy that we are getting here is very bad. We are getting only 13%. Here it's 26, and then it's 13 again. So now we could do a few things. Now I'm going to shift this PCA after standardization, then see the impact on the accuracy. So yeah, so the accuracy, there's no much improvement I expect for this one. So what I'm going to do is I'm going to get rid of this standardization, then see what happens. So accuracy still sucks. So I'm going to get rid of this PCA but keep the standardization. So this is how you play with your model to improve the accuracy. So now after getting rid of the standardization, getting rid of this PCA, you could see that my accuracy has gone up. Here for perceptron I'm getting 78%, for logistic regression I'm getting 86, for SVM RBF I'm getting 86 as well, and then for SVM linear I'm getting 91. So this is the comparison I'm talking about. So the actual diagnosis from the text file is cochlear pulse noise, then the predicted diagnosis is cochlear pulse noise as well. So such is the case for other output. So now why don't we just get rid of this standardization as well and see whether there is any impact on our results. The best accuracy that we got was 91, right? And that too for SVM linear. So here we got 91 again, but by this time we didn't do any standardization, no PC as well. And we got 91% accuracy for logistic regression. So that's pretty much it. So we took a raw data set from the website. So it's actually from the website. I downloaded it. So you could have seen. You must already know like where we should download the data from. It's in the second article of this course, if I'm not wrong, second or third, in which we discuss about the data sets that we are going to use in this tutorial. So we downloaded the data from internet, which is a raw data, and then we did all the feature mapping to like map all the character data set with the numerical data set. Then we got rid of all the columns that doesn't make sense. It has no impact on a model because it's all same. Like it's all true or it's all false, so it's not going to impact a machine learning model. And then the other one is to like we picked up the column classes that has high frequency of occurrence, which is more than 10. So and after that we did standardization, we did imputing, and then we did this we called different machine learning model, and then we printed out the accuracy. We did prediction and then printed out the accuracy. So the best accuracy that we could get is 91%. Okay, now what I'm thinking is, wait, let me go to the data set. Let me open, yes, this one. Let me go down. Let me get rid of this one. So we'll have only 4 different classes. Then see the impact on our accuracy. This is called cochlear pulse noise. Okay, cochlear pulse noise. So all we have to do is this. How convenient it is. We don't have to worry about anything else. Yes. Save this, press F5. Why is this an invalid syntax? Oh boy. Yes. Index out of bounds. Okay, understand, because we reduce the number of columns. But you could see here we actually hit accuracy of 94%. So let me go take care of that out of bounds. So it was out of bounds around here. So maybe I'll just give it 19. Okay. It's still out of bounds. Let me make it 9. Since we're reducing the number of rows that we have in our data, so we are hitting out of bounds on a test data set. So if you see here, we achieved a max accuracy of 94.7%. That's quite cool. So which is for logistic regression as well as SVM linear. So now let's play with this one. So we enable standardization. Then we see what happens. So till this is the best performer, logistic regression, then this is the worst performer with 47%. Thanks for buying this course. I'm sure that you'd learn how to implement machine learning for any projects that you want after going through all this tutorial series. Yes, hopefully you buy some other course from letsgo.xyz. So I'll talk to you guys in that course. Thanks for watching.